Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to homework problems. In a previous lecture, we dealt with EZ nomenclature, and at the end of that lecture, you were supplied with a set of questions that asked you to name molecules that had geometric isomerism in them, and to draw molecules in which geometric isomerism was designated E or Z. We're going to take up this homework now and begin with the naming of molecules by looking at this structure. Your first problem had a structure in which we had two methyls bound to a carbon that had a double bond. Off of this carbon was a methyl, and the main carbon was bound to a carbon that also had a double bond. An alkyl group was attached there that looked like this. And a carbon off the double bond that had a bromine and a CH2OH. Now the first thing you were instructed to do when asked to name or draw, in this case we have to name, including stereochemistry, was to ignore the stereochemistry. The first thing you do is just generate the IUPAC name. So we have to look for the longest carbon chain with the highest priority group. In this case, our highest priority group is OH. It is an alcohol. And we have a 1, 2, 3, 4, 5, 6 carbon chain. 6 carbons is a hexane. With an alcohol, we would drop the E and add OL. So that's hexanol. And then we have 2 double bonds. So 1 double bond would be hexene. 2 double bonds is hexadiene. So we have a hexadiene all. Numbering, to give the lowest priority, the highest priority group, the lowest number, we get, looks like, a hexa 2,4 diene 1-all is the one required. And the answer is yes, because the alcohol could appear anywhere along the chain. So hexa 2,4 diene 1-all. As far as substituents go, we have this alkyl group off of 3. The name of the alkyl group is a tert-butyl, so we have a 3-tert-butyl. Off of carbon 2, it looks like I missed a bromo. So we have a 3-tert-butyl, a 2-bromo. And then off of carbon 4 and 5, we have methyl groups, so we have a 4,5 dimethyl. If I'm alphabetizing, I have an M, a B, and the tert's hyphenated, so we don't count it, and a B. BU and BR. Well, it looks like BR, R comes before U, QR, STUV. So the bromo will come first, then the butyl, then the methyl. So here we'll have 4, 5 dimethyl. Bit crowded there actually. Let's make some more room. Let's move it back. So 4, 5 dimethyl. That's better. More room. So there's 4, 5 dimethyl, and let's fit in the 3 tert-butyl. So there's my 3-tert-butyl. Let's fix that E. 3-tert-butyl 4,5 dimethyl. And lastly, the 2-bromo. would be in front of the 3-terbutyl. There's a hyphen for it. Okay, now we're ready to consider the geometric isomerism in the molecule. Now we have two double bonds, and let's start by looking at this double bond at the left. If I split the double bond in two and examine the left-hand carbon of the double bond, I see two identical groups. If you have identical groups off one of the carbons of the double bond, you cannot have geometric isomerism. So the carbon double bond at 4, position 4, has no geometric isomerism, and we have no need to worry about the stereochemistry. However, if I look at the double bond that's a carbon 2, and I split that bond, and so I look at carbon 3, look at the two groups off of carbon 3, I see I have a terbutyl and I have this double bonded carbon, and those are different groups. On carbon 2 I have the bromine and a CH2, they are different groups. So the carbon double bond at carbon 2 does have geometric isomerism. Now I must determine whether it's EZ. If I start with carbon 2, I can prioritize the two groups off of carbon 2. By rule 1, we see and use atomic number. Bromine is a higher atomic number than carbon, so it gets priority. When we look at carbon 3, it's a little more complicated. In carbon 3, we have two carbons off of it. Okay, so we have a carbon here and here that we're starting to look at. Rule number 2 states isotopes of higher mass have higher priority. Well, that doesn't apply here. Rule number 3 says if two carbons are identical, proceed out the chain to the first point of difference. And we must proceed out the chain to the atoms that have the highest atomic number. And you must check every atom off of the carbon you're looking at. So I'm looking at the carbons I've drawn the dots by. And if I proceed out the chain, this carbon has another carbon. Well, he has a carbon. Okay, let's do that again then. I'll erase that. Proceeding out the chain now, this carbon, I get to do the double bond twice. That's rule number 4. Has a carbon. He has another carbon. Okay, so we're still tied. So let's go back to our original carbon. He has another carbon. He has a carbon. So again, we are still tied. Because of that, we now proceed out the chain. I select the next carbon, I proceed out the chain. Now since the methyls are the same, I just choose a methyl. This carbon has a carbon off of it. This carbon has an H. Now we've hit a difference. Hence, the double bond on this end is high priority. And what we have shown is that the two high priority groups on opposite sides of the double bond, that is E. And so this is E2-bromo. E2-bromo, 3-terbutyl, 4,5-dimethyl, hexa 2,4-diene 1-ol. Okay. The next molecule had an aromatic ring, benzene, attached to a carbon that had a double bond. Off of the bottom of that was a triple bond alkyne. Drawn like this. We then had a C with a CH2F. Okay. And then we had a C double bond O. And that was attached to O, which had an alkyl off of it. Now, as soon as I see this functional group, warning light should be going off in my head. This functional group is an ester. And you were told when you had to name esters that you take the carboxylic end of the ester and you redraw it and you name it first to get the name of the ester. So we're going to do that. And I'm going to pull off the alkyl group. And I'm going to put an OH here. Now what I have to do in order to name this is recognize the highest priority groups as carboxylic acid. Find the longest carbon chain with the priority group. That's 1, 2, 3, 4, 5. This is a 5-carbon alkane. It is a pentane. With the carboxylic acid, you drop the E, becomes a pentanoic acid. Double bond makes it a pentenoic acid. And the triple bond makes it a penteneinoic acid. In other words, I've got a pent 2-ene 4-ine oic acid. Pent 2-ene 4-ine oic acid. Okay, let's make some more room for that. Write that out again. Need more room. Okay, let's start here. That's a pent 2-ene 4-ine oic acid. An acid is a separate word. As substituents, we have several substituents here. For carbon 3, we have a phenyl. Okay, so we have a 3-phenyl. And then off of carbon 2, we have a methyl group that has a fluoro. And so off of carbon 2, we have a 2-bracket fluoro. And I would normally say 1 fluoromethyl, but I don't need to, because to be a methyl you only can have 1 carbon, so fluoro must be on carbon 1. A 2-fluoromethyl. Now, P comes after either the F or the M, so it doesn't matter. You know the phenyl's going to come next. So whether you pick the F or the M, it would have come first. And so you've got your 2. You have your fluoro. Methyl. So 2-fluoromethyl phenyl pent 2-ene 4-ine oic acid. Now you were told when you're naming esters, you drop the ic acid and you add 8. So if I was going to write this, I would have 2 bracket fluoro methyl three phenyl pent 2-ene 4-ine, oops, let's put that in proper, 4-ine OH. Okay, now I just named the alkyl substituent as a separate word out front, and that alkyl substituent is a tert. Butyl. Okay. So there is my IUPAC name. Now I have to look for geometric isomerism. Okay. And I have to localize the double bond, and here's my double bond. Split it this way. And look at the carbon here and there. If I look at the carbon here first, okay, look at this carbon first. I can check the two groups. I have a phenyl and an alkyne group. They are different. If I look at the other carbon here, the CH2F is different from the C double bond O. Because of this, I have geometric isomerism. So let's go back to the left-hand carbon and prioritize. If I start at this carbon and proceed out, I can show that this carbon has a carbon. Well, the alkyne has a carbon. I can go to a double bond again. This carbon has a carbon. The alkyne has a carbon. Now I can go on the aromatic ring this way. This carbon has a carbon. The alkyne has a third carbon. Okay, so they all have carbons, and it's tied. So now we proceed out. On the alkyne, I go to that carbon. So let's get rid of this. I check this carbon. And on the ring, it doesn't matter which way you go, so I'll try this carbon next. Now, because there's multiple bonds, I can go back on the chain. I'm forced to because of the ring structures. And so this may get a little confusing, but there should be 3 groups. So I can go back twice. This guy has a carbon. He has a carbon. He has a carbon. He has a carbon. He has an H. He has an H. And so you're still tied. So I proceed out along the chain. I hit another carbon here, but this time I hit an H. This makes the aromatic ring top priority. So on this side, so I just slowly disintegrate my aromatic. This guy is top priority. Okay. And it just turns out, if you memorized your trend that you were given in class, the aromatic benzene rings are higher priority than C triple bond CH groups. Now if we go to the other side, this carbon, let's proceed, this carbon, they're tied, proceed out the chain, the highest group you hit is a fluorine. This carbon, the highest group you hit is an oxygen. Fluorine's high atomic number. Great. So this double bond has the high priority groups on the same side. And the same side means Z. Now the question is, where do we put the Z? Where do we put the Z? Do I put it in front of the tert-butyl, or do I put it in front of the 2-fluoromethyl? Well, let's write this out again, because I'm going to put it in front of the group it is on. And the group it is on is the ester name, not the alkyl name. There is no EZ isomerism on the alkyl group around oxygen, so it does not go in front of the tert-butyl. The tert-butyl stays up front as a separate word, and I get Z hyphen 2 bracket fluoromethyl bracket 3 phenyl pent 2-ene 4-ine 08. Now, if the double bond had been on this group, if there had been a double bond with geometric isomerism on the alkyl group, then the Z would have come in front of the alkyl name. All right? So there you have it. Tert-butyl space Z2-fluoromethyl 3-phenyl pent 2-ene 4-ine 08. All right. Let's go on to the next problem. Next problem, we have a CH3 attached to a C double bond O. That is attached to a C that has a CH3 and a double bond carbon, bromine. This carbon has a C with 3 CH3s off of it. Interesting. A double bond, a C, an NO2, and a C double bond OOH. Again, a large molecule we need to name and include its geometric isomerism if it has any. We're going to generate the IUPAC name first. We find the longest carbon chain with the highest priority group. We have 1, 2, 3, 4, 5, 6, 7. Highest priority group is the carboxylic acid. So I can number it. 1, 2, 3, 4, 5, 6, 7. Okay. So there we have it. A 7-carbon alkane is a heptane. With a carboxylic acid, it becomes a heptanoic acid. With an alkene, it's heptenoic. 2 alkenes, heptene dioics. My alkenes are at 2,4. So this is hepta 2,4 dienoic acid. And acid is a separate word. Off of this, we have a 2-nitro. Off of carbon 3, the C with 3 CH3s, that is a tert-butyl. Hopefully you memorize your substituents. Carbon 4 is a bromo. Carbon 5 is a methyl. And what about carbon 6? What's a double bond? Oh, it is oxo. All right. So now we can incorporate these substituents. We use the O, the M, the B, and the N. So it looks like bromo's first. So bromo is number 1. Number 2 is tert-butyl. Number 3 is going to be the methyl, MNO. Number 4 is the nitro, and number 5 is the oxo. So we're going to have a 6-oxo here. All one word. No spaces. 6-oxo, and then the 2-nitro. After the 2-nitro, we're proceeding out. Number 3 is 5-methyl. Okay, so in front of the 5-methyl is the 3-tert-butyl. In front of tert-butyl is the 4-bromo. So 4-bromo, 3-tert-butyl, 5-methyl, 2-nitro, 6-oxo, hepta 2,4-dienoic acid. Now, we've got 2 double bonds. Let's see which have geometric isomerism. Let's start with the double bond to the left. Carbons 4 and 5. Carbon 5, I see I have this ketone and the CH3. Those are different groups. I have the bromine and the other double bond. Those are different groups. So 4,5 has EZ isomerism. Geometric isomerism. Carbon 2 and carbon 3, I have on carbon 2 the nitro and carboxylic acid. They're different. The tert-butyl and the double bond at carbon 3, they're different. So the double bond spanning carbons 2 and 3 also has geometric isomerism. So let's work on each double bond separately. Okay. If I'm going to proceed, let's start with carbon 2 and prioritize. Who's higher atomic number? Nitrogen or carbon? The nitro group wins. It has higher atomic number than carbon. If I go to carbon 3, I'm tied. I have a carbon and a carbon. Now this says proceed out the chain for the first point of difference. And when you proceed out, you always go to the highest atomic number. Off of this carbon, there are methyls. So the highest atomic group is carbon. Off of this carbon is a bromine. Bromine's higher atomic number than carbon. So that makes this guy the highest priority group. And you see your priority groups on opposite sides. So this double bond is going to be E. Now let's use a different color to try and do this on the other double bond. If we are looking at carbon 4, off of carbon 4 is a carbon, and off of carbon 4 is a bromine. So for carbon 4, for this double bond, carbon 4, bromine's higher atomic number than carbon. So on this double bond, the bromine's highest atomic number. When we get to carbon 5, we have a carbon and a carbon. If we proceed out the chain to the highest priority group, since it's a methyl group, you hit hydrogen. This carbon hits an oxygen. So its priority group is the C double bond O. That means the two red priority groups on opposite sides, and this group is also E. Now when you have to designate multiple EZ isomers, geometric isomers, on one molecule, whereas previously you could just say E and know it referred to this double bond that had geometric isomerism. Since there's more than one, you have to tell which letter applies to which double bond. So we have to give the position of the double bond by a number, followed by the isomerism, the stereochemistry. And you always list the lowest number first. So this is a 2E, comma, 4E, all in brackets, geometric isomer. So there you have it, 2E, 4E, 4 bromo, 3 terbutyl, 5 methyl, 2 nitro, 6 oxo, hepta, 2,4-dienoic acid. And make sure that you are able to determine EZ isomerism on molecules that have more than one double bond with EZ isomerism in it. Okay, next problem. Well, what have you given the name? Let's look at this structure, the name of which is provided, Z, 4, isopropyl, 5 propyl, 5 propyl, 4, well actually oct, 4, well it looks like the name you were given was the other way, so I'll write it this way it was given. 4 oct ene 2,7-dione. So here's the name you were given, and you asked to draw it. Now, the first thing in properly drawing the Z isomer is to forget about the Z and simply draw the structure. An octene 2,7-dione oct is 8 carbons. Write down your 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. We have diones at 2 and 7. So 1, 2, there's an ohm. 3, 4, 5, 6, 7, and there's an ohm. And then it says there's an ene of 4. 1, 2, 3, 4. So here's my E. Okay. Now we have a 5 propyl. And don't worry about where you put it for now. Just put it anywhere. So here's a propyl. And we have a 4 isopropyl. And so I'm going to draw it down as well. no idea if this is going to work out. And now you put in all your hydrogens. This carbon has one bond. That one doesn't need any. This has two bonds to it, so I give it 2. This carbon doesn't need any. This guy needs 2. And this guy needs 3. Okay, there we go. Now, I have drawn the structure for the name. I need to check out whether I've made Z or not. Now, I can double check to see if there's geometric isomerism, and this group's different than that. That group's different than this. So the carbons around the double bond each have a different group off of them. So there's geometric isomerism. Now it's simply prioritize. Prioritize. And if I do that, I look at the one carbon and double bond. So let's start with the left-hand one. There's a carbon and a carbon off of it. If I proceed out to the highest group, this has a carbon, he has a carbon. Okay, well, they're tied, so go back to the original carbon. Well, now all that's off of this guy is the H's, but off of this guy is another carbon. So even though there's oxygen further down the chain, you don't get to it. And this guy becomes the priority group. Okay, let's look at the other carbon, this guy. Here we have a carbon and a carbon. We're tied. Proceed out, I hit a carbon. Proceed out, I hit a carbon. Come on back. What else is off of that carbon? Well, I have an H. I have an H there. I have an H. I have an H there. Totally tied. If that's the case, I move out. I now consider this carbon and this carbon. If I proceed out to the highest group, I hit a carbon. This guy hits the highest group as an oxygen. So, oxygen's high atomic number of the carbon, that makes him a top priority. Now, what have I drawn here? What I've drawn here is E. They're opposite sides of the double bond. So what do I do if I want to make Z? Well, all I have to do is switch one of the sides, rotate one of the sides. And I can do this, for example, by taking this propyl and putting it up here. If the propyl's placed up here, instead of down, now these two guys, because the propyl's up, these two guys are on the same side. Now, if you want to make it clearer, you could write it this way. Two priority groups now are here and here. They're on the same side. And so you've made Z. All right. Now you may have drawn it flipped the other way. You may have a slightly different looking structure. Just make sure your two priority groups are on the same side of the double bond. You may put them both above. It would still be Z. All right. Well, our last question in this problem set is a complicated one that has two geometric isomeric double bonds, 2Z and 6Z, two terp-butyl, nine hydroxy, three seven Diisopropyl. 6-nitro. 2,6-nonadiene 4-inal. Wow. 2,6-nonadiene 4-inal. Al. Okay. Well, if we want to draw this properly on scrap paper, I would begin by just drawing the structure that is represented by the IUPAC name. And at first, I would totally ignore the 2Z6Z. Now, nonadiene 4-inal is the root name. Nonane is a 9-carbon chain. Al means aldehyde. So I would draw my 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonadiene is at 2, 6. 1, 2. So here's the carbon 2, 3, 4, 5, 6. It's carbon 6. I have a 4-ine. 1, 2, 3, 4. And I have an aldehyde. The aldehyde's always, when it's in the root, it's highest priority, so it's carbon 1. If I follow this, I have a 2-terp-butyl. So I'm going to just put that down. And I'm going to just draw it as CH3 3 times. A 9-hydroxy. Well, it looks like there is a hydroxy here of carbon 9. We have 3,7-diisopropyl. So let's put the isopropyls down. And 3, 7. So 1, 2, 3, 4, 5, 6, 7. Looks like this one here. One, 2, 3, 4, 5, 6. 6 is nitro. Okay. 6 nitro. Put that down. I think that's it. We've got everything. So now I just have to add hydrogens. Well, none there, none there. Looks like this is CH2 here and a CH2 here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yes, that looks good. So there is my molecule. Now, if I look at the 2 double bonds, indeed, if I check them very quickly, I'll see there are different groups at each end of the double bond. So if I look at this carbon, for example, of this double bond, there's a nitro and the alkyne. If I look at this double bond, there's the isopropyl and the CH2, and they are very different groups. So both double bonds have geometric isomerism. The question is, did I assign it correctly? Well, let's take a quick look. Let's start with the carbon 2 double bond, and let's look at this double bond first, this carbon. If I proceed out, I'm comparing these 2 carbons. There's a tie. So I proceed out to the highest priority group. I hit an oxygen. I will hit one of the C's of the methyls on the terp-butyl. Oxygen's higher atomic number. Hence, the aldehyde is the higher priority group. Now, what about this K? Well, if I go to this carbon, now I have to compare these 2 carbons. These 2 carbons are very similar, so I proceed out the chain. This carbon hits a carbon. He hits a carbon. Okay, so we're tied, so we go back to our original carbon. I proceed out, I hit this carbon now, a different carbon. You can go out the triple bond 3 times, so I go out a second time to it. Now off of this carbon is an H. Proceed out the third time, you hit a carbon. Carbon's higher atomic number than H, so the substituent is on this side. And indeed, they're on the same side, so this is Z. I've done my prioritization. So let's continue. What do I have next? Well, if I do it over here I have, off of this carbon, I have a carbon and a nitrogen. Well, nitrogen's higher atomic number. There's no tie. He's the higher priority group. What about this carbon? Well, on this carbon, I hit this carbon and that when I proceed out. If I proceed out again, I hit a carbon. Well, I can hit this carbon. Go back to my original carbon. Next thing off of it is an H, but I've got another carbon on this guy. So he becomes highest priority. Again, it looks like they're on the same side, so this guy's Z. I have lucked out. I just happen to have drawn it correctly. So certainly I could leave it like this. They are both Z, and just copy this off my scrap paper once I've checked it down so. Or I might want to clean it up a bit when I copy it, and I might draw it this way. For example, I might say, okay, I'm going to put a double bond OH here, and the terbutyl, leave the CH3s in brackets, put the double bond here, have my methyls, running out of room. Up here, my C triple bond, down to my C double bond with its NO2. And then I could put my CH3. And up here, my CH2, CH2, OH. So I could draw it this way if I wanted to, showing more clearly which groups are the priority groups in that. And just draw it in a way that's visible. Okay, there you have it. Now I could have drawn this whole structure flipped the other way, and so there's several ways to draw this structure, but either writing it as the top structure was written or as the bottom structure would have been acceptable and would have gotten you full marks. Okay, these were a little more complicated than normal IUPAC nomenclature because of the additional EZ isomerism or geometric isomerism found in the molecules. And you have to be able to draw the molecules when given the name or name them when given the molecule. Thank you very much.